Okay, hi everyone. We'll be going through a small user journey today. I think a lot of the talks here are a little more on the conceptual side. So we're going through and learning a lot about technologies. I'm going to do something slightly different to break the monotony, if I may, and talk about how we actually helped migrate one of our clients at one to N from a completely managed stack to completely open source. So to begin with, a little about myself. Hi, everyone. I'm Kshitish. I've been working as a software engineer for the last 5 years. I've stopped pigeonholing myself as a backend or a SRE anymore. It's all just falls under software engineering, and most of my experience has been at startups. So a lot of like on the pace learning, what I like being called just learning in the pits of hell, where it's all trial by fire. So that's where I'm coming from. The agenda that I want to go through today is basically we want to explore what an entirely managed analytics pipeline looks like. So, what happens when you just say, hey, I'm going to go full AWS everything? How that looks like, what are the benefits it gives us, what are the pain points of it, right? Then we'll look into how we can actually switch from this to completely open source, completely self hosted, what that looks like, what's and all, and when is the time to switch. So to begin with, let me set some context, right? We were working with a B2B fintech client. Again, they're in the cross-border payment space. Huge scale, they're doing around 50 to $70 million in transactions daily. And because of this, in their analytics pipeline, they're processing multiple terabytes of data. So we started with around 5.2 TB, which is a lot to handle for any system. So obviously, when they were initially setting up their entire system, they said, "Hey, we do not have the maturity and our organization scale, and we do not have the manpower required and the expertise in our organization to actually set this up ourselves." So they went with something that looked a little like this, right? So you have your Postgres database. Like everybody else in the world at this point, they're using Postgres for transactional databases. However, would anyone like to hazard a guess as to why you can't just run everything off of Postgres? Anybody? Okay, cool. So the issue with Postgres is, right? I don't know if you've ever heard this, but we have a great saying that Postgres is always the second best database for any use case you want. Because it has a lot of features, it has a lot of open source support, and a lot of connectors have been written for it as well. You can technically use Postgres for your analytics pipeline, but the issue comes with using the right tool for the right purpose, right? So with Postgres, because it's a transactional database, something that is row oriented, that means all of your data is stored in one contiguous row in your memory itself. So whenever you're scanning through records, right? Let's say I want to select a user with ID 123. What it ends up doing is it'll read that entire row into memory, and after that it'll select just the fields that you want, because obviously you don't want all the metadata. I have no interest in when it was created, I just wanted the name. So that's why it causes a lot of issues when you're reading through millions and millions of records, which is what you end up doing for a lot of your analytical use cases, right? So in cases like this, we end up using things like AWS Glue, which is a little more column oriented. It is a lot more optimized for aggregations that you run over millions of records. So with our client, they had set a Postgres source, which was essentially syncing to AWS Glue tables. For this syncing, they were using something called DMS, which is just a data migration tool that AWS gives you. And using this, they're doing something called a CDC sync. I'll talk more about what CDC is later on down the line. Now, obviously, if anybody here has ever worked on analytics pipelines, there are tons of ETL jobs that are required because data in its own is messy. You need to clean it up and then reformat into ways that you can actually use it. So we have a similar thing working here using glue jobs, which are essentially Apache Spark jobs running in Python. So these help us take our raw tables, which are basically a one-to-one sync of what was there in Postgres, create cleaned data lakes. So this will have some level of data cleaning, making sure that you're only picking things that are necessary for you. But this is still a little bit messy. So on top of this, we consolidate data into something called data marts. So let me give an example here, right? Again, because our client is a fintech company working with cross-border payments, the most important thing for them are actually foreign exchange rates, right? So your foreign exchange rates are changing every minute. However, when you're looking at it from an analytical point of view, what matters to you isn't, hey, what is the exchange rate between USD and INR right now, which honestly something we don't really want to talk about at this point. What matters is how has the ISD versus INR, USD versus INR rate been changing over the course of a month? Because what the rate is now just tells me, hey, if I earn a rupee, what can I spend it in dollars right now? When you look at the change, what is the delta, what is the trend, that's when you can start making business decisions on this, which at the end of the day is why anybody needs analytics. Why does the world build analytical pipelines? Is to inform these decisions that are happening, right? So once we have our data marts consolidated, all of this is still in a table. Now I dare anybody here to go to somebody who is from business operations and give them a database connection. Like, hey, here's a terminal, figure out what to do with this data. They're going to scream at you. So on top of this, we have another layer called Athena. So Athena and QuickSight are basically AWS services which let you query these like glue tables to generate data sets and charts on top of it, right? So at the end of the day, this is what our end user interface is. This is our primary data source, and this is all the spaghetti in between, which actually lets us serve data to that end user service, right? Now, what is the main problem that one can run with the system? Because surely it has been running well, the client was happy, but still they required a change and a migration to open source. That reason is one thing that a lot of us here would be familiar with. If you guys haven't come across this, you will come across this word soon enough, which is this is a cost center. By a cost center, what it means is this entire stack costs the organization a certain amount. So in our case, it was currently costing $13,000 a month, which is palatable. However, the company themselves, they've expecting projected 3x growth to happen. They have themselves secured funding recently. So they're expecting these costs to go up to 35 or even $40,000 a month. Now, at $13,000 a month, you can make a case to the leadership team and the investors ki, hey, this is bringing us this much value. The analytics is helping us make these informed business decisions. At $40,000, that argument becomes much weaker. There's also the issue of limited control. With managed services, it's a thing of, hey, you're given a small dashboard, there's a small settings page. What is there is all you get. There was a limit to how much we could tune compression, which is how we ended up with 5.1 terabytes of data. There's a limit to how you can control resource allocation, right? You have your different types of EC2 instances, but then per hour pricing is what you get over there. There's a very, very limited amount of control that you have over your system. And as you scale, what you realize is one size fits all solutions work when you fit in that size. The bigger you get, the more custom your solutions are going to have to start becoming. And that is where open source helps a lot, right? Now, within open source, there are a lot of alternatives for analytics that we looked at. Obviously, open source was not the only solution we wanted to go through, but what we ended up with is a stack that looks a little like this, right? Now, I'll go through all of these stages, but what I'm also going to talk about is how we made the migration from managed to open source. Because you can't just dump in a new system and expect it to work. There has to be a proper plan. So let's go over the softwares that we had, right? The most important one was ClickHouse. Now, ClickHouse is an analytical OLAP database, which is a little different from your traditional OLTP databases like MySQL and PostgreSQL. I won't really go into the depths of it. If you guys want, please come. We can have a talk later, and I'll be more than happy to explain how this works. But the be all and end all of it is ClickHouse is, for many reasons, very, very optimized for analytical workloads. It not only helps you store large amounts of data in relatively smaller disk spaces, it also helps with query latencies because of the way how data is structured within the database itself. So When we chose ClickHouse, we knew that this was the central piece of our architecture, and everything in the pipeline had to built around ClickHouse, right? So we chose PeerDB, which is another open source project which was actually acquired by ClickHouse not so long ago. And this PeerDB is what is allowing us to sync from Postgres to ClickHouse, right? Within ClickHouse, again, we need to have our ETL jobs, which is transforming data. For that, we're using something called Prefect, which does workflow orchestration for us. I'll go a little into depth into this as well. And then Apache Superset becomes our end user interface that we're giving to the business team, right? So at the end of the day, this is what the new architecture looks like. A little too similar to the old architecture, right? If you can see, there's just one-to-one parallels. It's a little bit of a spot the difference game that you'll have to play if you actually want to find the difference. And this is a very intentional choice as well, because over here, what we're trying to solve for is the costing of the previous managed architecture. What's not broken is the process itself. The business team has been working with a certain set of rules and processes that they have. The data analysts have built certain data marts on Glue. What we wanted to do was supplant the system instead of replacing it with something completely new, which means for the users, the experience isn't that different, but underneath that sheen, the dirt underneath is completely removed. So again, similar to how we had before, we have a CDC sync, we have ETL jobs, and we have an end user interface. Now, in order to set this up, we need to make sure that we are building this alongside the existing architecture. So for the business team, there is absolutely no break or downtime in between when things are happening, right? So we went about it in 4 phases of migration. The first phase was actually setting up the ClickHouse cluster. So, if any of you have worked with database clusters, right, you have one primary write instance, and then you can have n number of read instances with scale up. ClickHouse is a little different because it works on something called a multi-master architecture, which means if you have 3 different nodes running in the cluster, your client can connect to any of those nodes, right? So your client can connect to ClickHouse 1 or ClickHouse 2 over here, and they both act as both write and read instances. So with ClickHouse, there is something called eventual consistency, which means at a given point of time, there might be inconsistencies between data in one node and the other. Now, for something that's transactional like Postgres, this is very bad. Why the hell would you want different data, right? It's a huge problem. Why this works with ClickHouse is because with analytics, you're never really working with point in time data. As I said earlier, what the USD INR rate is right now doesn't matter. What matters is the trend that's happening. So little inconsistencies which are resolved over the course of 5 to 10 seconds of lag are usually okay, right? So this is what our architecture looks like. You have 2 ClickHouse nodes, which are basically your DB instances, and you have 3 nodes of something called keepers. Now, if anybody here has worked with Apache Kafka before, the word keeper should be triggering some PTSD for you. That's because these keepers are the same as zookeepers that we use with Kafka clusters. Their job is to maintain quorum, which means when something is entered here, these 3 keepers are responsible for making sure that the data across 1 and 2 is consistent. Now, with this, again, because we are completely on AWS, we decided to go with Graviton based instances, which are ARM instances. Again, because the performance hit wasn't really anything significant, and there are a lot more cost benefits. And we were able to use open telemetry for setting up observability over the entire ClickHouse cluster itself, which means your database metrics, how much CPU it is using, what are the longest running queries. All of this can be streamed to whatever logging application you have using OpenTelemetry. And that is how we ended up going from $6,400 per month being spent on glue tables with their S3 storage in the backend to just $3,600 per month. We are almost halving the entire cost just here itself. Then we go to phase 2, which is, hey, we have our ClickHouse cluster set up. There's just a database, there's no data in it. What's the point of a database without data, right? So this is where we start getting the CDC sync from Postgres using PeerDB. Now, CDC stands for Change Data Capture, right? What this means is in Postgres or MySQL, whatever transactional database you're using, you will have something called replication slots that you can create. These replication slots essentially follow your write ahead log or your WAL. So whenever data is being inserted or updated in Postgres, that creates a record in the WAL. These replication slots read it from it, and PeerDB will immediately sync that data to ClickHouse. So this is a real-time sync of data that is happening, which means you can get close to real-time analytics, which means, hey, I can go and check what happened in the last 5 minutes versus being limited to, hey, my data only syncs once an hour. So I can only give you analytics of the last 1 hour that I have, right? So that's why CDC syncs are very important. Now, the main reason for choosing PeerDB was because it was a proven entity. Again, this is a completely open source project that is officially supported and owned by ClickHouse itself. So working with ClickHouse was a no-brainer. It just immediately integrates. But what CDC also, what PeerDB also allows you to do is you can set it up as a data migration tool for anything you have. Let's say you want to shift from data from Postgres to Mongo or MySQL to Postgres. It'll let you do all of that. So this is what the dashboard in PeerDB will look like. You can see at what times you had things happening, when certain records were deleted as well, which is where you see this lag going down, right? So that was phase two. For phase three, now we have data syncing to ClickHouse. We need to run our ETL pipelines. So for ETL pipelines, we used something called Prefect. Prefect essentially is just a workflow orchestrator. So you can set your workflows ki, hey, I want this operation to run on this database and the result should be written to this database, right? And with Prefect, you can run this either on a cron, event-based triggers. There are multiple different ways of doing it. Uh, During our first talk, we also had a mention of DBT, which is essentially just a open source tool which lets you define your database models in code. I think if a lot of us are coming from Python background, you'll have used SQL Alchemy for this in the past. So with DBT, what we can do is for all of our data lake and data marts, the schemas for these are programmatically written. So anytime I need to make an update, ki, hey, the engineering team has made an update where they've changed the schema of one table in Postgres, I can make these changes in DBT itself. And now all of these changes get shipped as one release, right? So within Prefect, this is what a workflow execution will look like. You have your logs, you can generate artifacts from this workflow run as well. And what Prefect does really well is not just let you see how a workflow succeeds, but very importantly, see how it fails, right? So you can see for each task, we not only have the time it took to execute, but when these tasks fail, which are steps in your workflow, you can isolate that exact step and see what was going wrong. Because let's be honest, a well-running workflow is what is expected. A broken workflow is the main thing that you should be focusing on. And now that we have our data marts created as well, all that's left is to give it to the business team. So Apache Superset essentially is something similar to Metabase, if a lot of you guys would have worked with it, right? This basically just allows us to run ClickHouse queries using the ClickHouse HTTP APIs. And with the data that ClickHouse is returning, you can use it to create dashboards. You can use it to create charts that look very nice in investor meetings. But on top of that, what you can also do is set reports and alerts, right? So think of this. Let's say you have a certain merchant who is doing like $100,000 in Bitcoin yearly. They are a big enough customer where they'll want a daily report of, hey, what is going on? How are the foreign exchange rates fluctuating? What is the rate of Bitcoin going like right now? These reports can be sent on almost like a cron job basis for them. And alerts are very important because let's say you have payment successes, right? If there are errors in that payment API call beyond a certain point, this should let us know, okay, hey, we are having an issue with the bank specifically immediately over there. So one really good thing about Apache Superset is that when it sends these alerts, right? This is what a chart will look like in Apache Superset. Again, this is just one example. You have multiple different things you can do, tables and pie charts. But what Apache Superset does is it'll actually use a headless Chrome driver instance to take a screenshot of these charts and send it along with that alert. So whenever somebody who is not that technical is they're getting a mail, they're getting a Slack message that something has gone wrong, having that added context of, okay, this is exactly what your metrics look like right now, gives that level of ease of mind where you're like, okay, I don't have to go looking for it. I don't have to immediately panic. So at the end of the day, once all of this is done, what does the outcome actually look like, right? We ended up reducing costs by 70% by shifting to a completely self-managed open source pipeline. That 70% essentially looks like $108K annually. So they can employ a lot more DevOps engineers to maintain this. More than that, what I'd really like to focus on is the 81% compression in DB size. So I had mentioned earlier that one of the greatest things about ClickHouse is how it lets you store a large amount of data in a small disk space. That's because it uses by default GSTD compression. There are a few more tricks that it does, but at the end of the day, because the compression is tunable and you can also alter your table schemas in certain ways that it encourages even higher levels of compression. This 81% is not atypical for ClickHouse. It's actually very normal and par for the course. However, these are all these three metrics, right? Your 99% availability, 70% cost savings, 81% compression. These are all really good metrics to give to the business team. What really matters to engineering teams is having that control, right? A, we are no longer locked into AWS. If I want, I can take this entire stack and deploy it on GCP. I can deploy it on my own servers if we ever need to do an on-prem deployment for this, right? We have complete control over how we want compression to happen, over what kind of resources we want to allocate to this from a compute standpoint. And that control is what's going to help us scale. So this all seems very impressive, right? Come on, man, this 70% cost reduction. Who the hell wants to pay 70% more for their infra? Nobody, right? So then, why would anybody ever go with managed services in the first place? Isn't it better to just do it right from the start? Set up everything self-hosted, open source, and then you can go ahead with it? Well, the truth of the matter is that open source isn't always the right answer, which is a crazy statement to be making at this meetup. But I'll follow that up with it is more often than not the right answer. It all comes down to economies of scale, right? For a small startup, a small or medium enterprise, right? You want to be able to get started with things as soon as possible. With the advent of AI, code, quote unquote, is a solved problem, which I will laugh at in whenever somebody comes and talks to me about it. But you cannot ignore the fact that getting to market as soon as possible is a very important thing from a product lens, right? So having your processes set up, having your analytics pipeline set up is very important, and getting it done as soon as possible becomes crucial. This is where managed services really shine. Is a you do not have to worry about the SLAs, about your backups. They are a solved problem for you. The effort required from your end is not as much. What's required from you is your wallet. So sure, when you are just working with maybe let's say 1 terabyte of data, right? This is fine. $13,000 per month is something I can stomach, and at an even smaller scale, right? When you're just starting out, the cost difference between managed and open source is not going to be that different. The problem happens when you start scaling up because these costs scale with you. And then it becomes okay, is my analytics pipeline giving me value worth $13,000, worth 20, worth 40, worth 100K a year? And the answer for that increasingly becomes no, 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 and it keeps getting louder, right? So that is when every organization in this world is going to reach an inflection point. One point where they'll decide that it's worth the effort to shift to open source, because in the long term, open source self-hosted is where you're going to have security for your organization. not just security from a data security point of view, but security from the sense of operations. Your operations are secure. You know the processes that you're following are securely in your hands. And that's why at the end of the day, self-hosted is always going to be the end game. And that's why open source projects are really important, because without them, we cannot reach this scale. Yeah, so that's it from me. Thank you, everyone. If you want to reach out, please feel free to hit me on LinkedIn. The QR code will take you to a small blog page that we hosted 112. This entire talk was actually talk based on a case study that we've written, which you will find on the same QR. If you have any questions, you can ask them now, or I'll be more than happy to talk with you all later. Okay, thank you.